Hello everyone, you're welcome to this channel once again. Today we have another peculiar question from the aerodynamic point of view, showcasing dynamic similarity. Now let's read through the following question. Consider an aeroplane fly at a speed of 50 meters per second at a sea level where the pressure is 1 atmosphere, the temperature is 293.15 Kelvin. Find what velocity a wind tunnel test of 10% scale model will be performed to maintain dynamic similarity, that is, same Reynolds number. Would such a test be meaningful? Assume the tests are performed at the same temperature condition. Take into account that the sound velocity at the sea level is approximately 344 meters per second. Once again, an aeroplane fly at the speed of 50 meters per second at the sea level with a pressure of 1 atmosphere and a temperature of 293 Kelvin. Find at what velocity a wind tunnel test of 10% scale model should be performed to maintain dynamic similarity, that is, same Reynolds number. Would such tests be meaningful? Assume the tests are performed at the same temperature condition. Take into account that the sound velocity at the sea level is approximately 344 meters per second. First of all, we need to deduce what the question is asking us by saying dynamic similarity. So dynamic similarity is when the Reynolds number of the model equals the Reynolds number of the prototype. Now, we know fully well that Reynolds number equals the velocity multiplied by the density and the size, which could be diameter over the viscosity. So that gives us the Reynolds number of the model multiplied by the density model multiplied by the velocity model and the diameter model equals the density of the prototype multiplied by the velocity of the prototype multiplied by the diameter of the prototype over viscosity of the prototype. Don't let us forget that prototype is what we are referring to full scale in this particular question, which is the real aircraft, while the model is the one being tested in the wind tunnel test. Now, from this particular equation, we were told that they were performed under the same temperature condition and so many other dynamic conditions. So therefore, the viscosity will be equal to the prototype. So that will be cancelled. The density are the same. So the density will be cancelled. So that gives us, the equation becomes Vm dm equals Vp dp, and we are asked to find which is the velocity for the model which is under the wind tunnel. So our Vm equals Vp dp over dm. And don't let us forget that dp over dm, which is the size of the prototype over the the the, the model, equals 10%. So that gives us 10. So that gives us our velocity for the prototype, which is 50, multiplied by the size, which is 10. That gives us 500 meter per second. Now we are asked that would the test be meaningful in this particular question? How do we deduce that? We're asked to find out would the test be meaningful. Assume the tests are performed in the same temperature condition. Take into account the sound velocity at the sea level is approximately 344 meter per second. Don't let us forget that Mach number equals V over A, that is the velocity over the sound velocity. And we're told that the sound velocity is 344. So therefore our Mach number equals the velocity, which is 500 over 344. That gives us 1.4, roughly 14.8, which is approximately 1.5. That shows that the test is undergoing compressible flow. So which is not applicable to wind tunnel. Whenever Mach number is greater than 1.5, that is compressible flows. And that will include shock waves and sonic boom, which is not applicable to what we are doing in the wind tunnel. So therefore, the case test might not be meaningful. So the answer is no, because it's against the physics of the incompressible and compressible flow. So the test will not be applicable here. Thank you for staying tuned.